Good morning and good evening, depending on where you are. This is a webcast about the customer conversation, the conversation that everybody has with their customer when they are trying to figure out what's going on. How can we help that customer? My name is Peter Larsen. I am a director of platform migration at DBbest. And I have presided over a lot of migrations to different platforms between databases and systems and into the cloud, Amazon and Google and Azure. So this is our talk for today. DBbest is a company that's been around for a little bit. We're spread out over the world in at least in the Western world, and we have a past with some Microsoft buying some of our software. We have created some database migration software in the past that they were interested in, and that has very much been the start of the company. Now we're much more diversified, over not quite 500 people yet, and spread out over the world. And you might have seen, if you're in the database world, you might have seen the SQL Server Migration Assistant, which was software from DBbest. And we have made many more types of software packages, and I'll talk about some of them briefly. But it's not so much about us; it's very much about the customer conversation, which we'll get into. But just so you know what we do, we oftentimes get called up when the customer has an older platform that needs to get with the real world. It might be an old mainframe. It might be an old database platform or an old version of a database platform which no longer is cost effective or has the right features or runs in the right places. And then it becomes our job to take that database and move it over to something that is better to maintain, perhaps cheaper, perhaps scales better, and so on. We very oftentimes do this at the same time as moving the customer to the cloud. And everybody seems to be wanting to go to the cloud for a lot of good reasons. They get, and you probably already know, some of the reasons to go to the cloud, right? You can dial up and down your resources at any whim, and in many cases, depending on your needs, you can save on the actual usage, and in other cases, you can certainly save on the operations and the upkeep of the infrastructure. So there are many, many reasons to go there, and we help people lift their existing applications into the cloud. But sometimes, as you may know, if you've dealt with Azure and AWS and GCP and maybe other clouds, is that the conditions are different in the cloud from your data center. There are lots of little things that will have to change. And that is where we provide our services. It's also typically a time when some of our customers encounter DevOps for the first time. They have not been used to thinking about infrastructure as code, and we help them on that journey. There's a fair amount of application development going on in DBbest. We have a number of applications for data management. So imagine the problem of having moved this database into the cloud or having moved this database from one platform to the other. We then need to do some testing and making sure that it actually works the way it's supposed to in the new platform, and we have tools for that. We have tools that can compare the data across platform stacks. We have tools that can compare the functionality of procedures and functions and stuff like that, and otherwise take care of the migration process. We also make a bunch of mobile applications, and I'll show you some pictures of that later. So there is a large application development team at DBbest that undertakes web development and server development and microservices and all sorts of exciting stuff. And then just because we have all these many consultants, we can go to a customer and say, we can help you think. We can help you do design services, to consider a change in your environment. We can go in and look at your existing settings and tell you if they are the optimal settings for the workload you're running. We can estimate how much it would be to change what you have today to move into the cloud or to change out of platform. Those are just some of the consulting services. It could be a security check. There's any number of things that don't leave a product behind or any big change. They leave a document that tells a story that then allows the customer to make decisions. And we do a lot in big data. Some of our customers have lots of transactions collected over many, many years, which they would like to project into the future to predict what types of things to keep in which warehouse. That's the type of predictive analysis we are doing for several companies. We're doing data mining of existing data. We are dealing with IoT, with collection information from windmills and the school buses and stuff like that. So it's very, very exciting, and we're starting to play with machine learning as well. And the clouds provide an excellent, very, very scalable infrastructure for these efforts. So most of this work happens in the cloud, but we also help people with their BI solutions on-premise. We also offer customers to manage their existing infrastructure. This is oftentimes desirable when the customer is really focused on doing something else that's the primary business. They don't really want to be managing an IT environment as well. So we are able to do sort of the 24/7 looking at those machines, making sure they're healthy, and providing dashboards for the customer and so on. Here's an overview of all these things. I don't want to go into all of the individual ones, but you will be able to download the deck afterwards and read through some of these. And you can go to our website, dbbest.com, and see some of the many solutions that we have created for different people and the many products we have. There's a lot of content. Here's a little snapshot of some of the flashy applications that we created. Much of the work we do is not very flashy, right? When you if you create an infrastructure of 100 servers in Azure or a data warehouse in AWS, it doesn't look very pretty. But with all the GUI apps we have made, we've made hundreds of mobile apps. That's something to show. So that's one of the few sort of pictures of the stuff we make that I can actually show you. And there's some really exciting apps in between that deal with many of these are medical data, but it goes all across the field. So we basically bring process and people and tools to the customer, and I'm going to talk specifically today about how we get into the customer's head, how we try to understand their problem in order to provide that solution. So the customer calls the doctor. In this case, we're the doctor, and we say, stick out your tongue and say, you have a problem that we might be able to help you with. And all of the things that a patient is concerned about, our customers are typically concerned about, because this cure could leave a scar, right? This cure could be expensive. And so on and so forth. The cure could take a long time, and we're in the middle of something that, for example, takes a long time, it seems. And we also have a responsibility in this regard, right? We are here to make money, but we are also, in many cases, much more knowledgeable than the customer, which puts a responsibility on us to do the right thing. We have a responsibility to advise them to go in the right direction. Oftentimes, though, the customer knows what they want. And depending on who you're talking to with the customer, you might get different messages. And this is very important when you talk to the customer and figure out what they are really needing, because it's not just one person, it's a whole family you're talking to, and they have very different perspectives. From the person, maybe the CIO or the CTO, who is sponsoring a particular change, down the ranks. If we're making a change in the environment, for example, that will remove an old platform, there's going to be some people in the room, perhaps, who are going to be worried about their future job. If we have a manager in the room who needs to take care of the education of his people, or somebody who needs to hire new talent, there are lots of repercussions to the advice we give, and to what the company, how the company needs to behave going forward. So it's not something to take lightly. There's also people in the room who care about how this effort is going to take away resources from something else that's going on, how it's going to interface with other rollouts, and how it's going to maybe take bandwidth away from somebody else. What about procurement, right? There's a lot of stakeholders that we have to take in and kind of hear all of those viewpoints. Even though we are obviously making it for the person who pays the bills, we have to listen to all of these people, because oftentimes when we come in and have this conversation, this is one of the few times that all of these people are in the room together. They may be so far from each other on the org chart that they have no reason to talk together, but today they're together in a room with us, either virtually or physically, to talk about a project that touches them all. And it sometimes creates some interesting people dynamics, and we have to kind of put our psychological hat on a little bit as well to figure out who calls the shots. And somebody else may not be the person to make the final decision, but if they say no, the whole thing doesn't go. So there's a lot more than technology to this conversation. And as I quote at the bottom, it's not unusual, and I've heard this several times from people engaging with us and having the customer conversation, that they learn more about their system in a few hours than they had in years, simply because we collected all of those people into a single room and systematically went through their system. One of the things that really impact the conversation with the customer is their maturity. This is a depiction, there are many different versions of this, of the journey that different companies go through as they get smarter and smarter about their own infrastructure. They, if they are very sophisticated, high on the pyramid curve, we are able to get blueprints of the infrastructure. We're able to get plans. They have capacity figured out. It's all secure already. But that's not the case most of the time. Most of the time, we actually encounter customers down towards the bottom of this curve. And then the job that we come in with is a combination of solving the immediate problem that's on paper with all of the associated problems of not being a very well managed environment. And obviously this is something we say very softly to the customer, but it's one of those things that we have to assess as we go into a customer, where they're really at in their thinking, and what kind of language, what kind of things are they receptive to, and what kind of artifacts might there be in the organization for us to use in getting our minds around that problem. So this is important. You can imagine going into a company and essentially using the first little bit of time to assess where they are on the curve, and then tailor your questions to them accordingly. This guy here is a depiction of the human body relative to how many nerve ends there are in the different parts of the body. I thought this was kind of interesting in the context of discovery, because when we look at a customer problem, we are gathering a bunch of facts, and whatever we gather in facts is how we see the problem. So if we gather the wrong facts, or we don't gather them all across the system, we will get a very distorted view of the actual problem. So we try to avoid this pitfall by going in from multiple directions. Some of them mechanical. We are able to go in with a system that's already made that can talk to the existing Windows servers and Linux servers and their associated workloads and databases, and collect a bunch of facts that may or may not be easily obtained by just asking people. They may not sit in a spreadsheet somewhere. They have to be measured. So we will often collect this information for weeks or maybe even months, depending on the company, if a large infrastructure change is going to happen. Things like the existing maintenance of the environment is important, because then you can see what kinds of trouble they have, right? If you look at tickets that have happened over the last year, you get a good picture of which things are working well and which things are not working as well. And if they are sophisticated and they have a CMDB, you can ask the CMDB for an inventory of everything there is, and use that for the basis of your conversation. But it's all about the maturity, whether these systems are in place or not. We will typically be investigating the actual source code, right? We get a problem or we get a desire for a new configuration, and we inspect the source code of the existing components in order to see what kind of changes need to be made. So if this is a database migration, for example, we will get all the DDL for the database, and we will pore over that and use our different tools on that code to see what needs to be done to this code to fit in the new environment. If they have a DevOps process, we'll look at the Ansible code and whatever systems they're using to manage the deployments, because that gives us a blueprint of what the environment looks like. We also care about how they currently test their systems, because one of the huge areas of making a change to the system is that we want to validate that this change is going to be correctly implementing all the existing functionality. And it's amazing to me how many of our customers actually don't have a comprehensive set of tests for their environment, because, hey, it's been running for many years, and we're just making little tweaks to it, so why should we be testing it all that much? And one of the notes you see here is threat models. I don't know if you're aware of what threat models mean, but it's a methodology to actually, in a structured way, talk about the vulnerabilities of an IT system. And that's something I normally don't expect people to already have, but it's something that we, in some cases, go in and create as a way to show the customer some of the other changes that might need to be made in order to stay secure. You can gather information from other sources. The query cache, for example, going in and sitting essentially between the application and the database and listening to the traffic. That's a good way of figuring out which parts of the database is the most important. If it comes to the point of moving that database somewhere else, we may in fact have to have a map of what's inside of that database from a content perspective and from an importance perspective. And that query cache allows us to see where the action is. It also gives us specific values for calling functions and procedures. So if we were to make some comprehensive testing of the new system, we can use the query cache to deliver some specific values to us. When we talk to the customer about their architecture, these are the three architectures that are relevant to us. The most obvious is the current and the future, right? We have to assess exactly where the customer is today in order to understand the problem and the moving parts. And the future architecture is also obvious. This is where they want to go. They maybe want to go to the cloud, or they may want to migrate a workload to something different. But the transition architecture is actually important for us because sometimes the transition from current to future is a prolonged process. It might actually take months in some cases. And I have an example later on where we are where the customer has a number of customers, each of whom have to be cut over individually, and that is just going to take months to do. That means that the transition architecture probably has a leg in both the current and the future architecture as we move over, and only once we're done moving everybody over are we fully in the future architecture. So those are the three we'll concentrate on. In the current architecture, I oftentimes talk about the big rocks. And this is where an experienced architect really shows their value, because they have a sense of what things are easy, what things are hard. So the big rocks are things that either are going to take a long time, or maybe they're intellectually challenging to do. But when we establish the current architecture, we want to know about the thing that the customer says they have a problem with, and then we want to discover all of the implications, all of the connections. The data inputs and outputs, you know, if it was a database or an application, they're typically connected to other databases and applications, right? So if you do something to that one workload, you're going to impact in some shape or form all of the others. So part of our job when we assess where they are in order to figure out what work to do is to chart and map all of that extra stuff. I call it connective tissue. Like in a human body, right? The organs have connective tissue to the rest of the body, and that's important in this context because you might have to change a driver or reformulate a query and stuff like that. Some of the things that we'll discover can be there already. There may be a monitoring system already in the environment. I talked about the CMDB earlier, but there also might be alarms and alerts and performance metrics, all of which we can use to characterize this environment, which might mean something for where they're going next. So where are they going? I mean, it is really open-ended, right? They could be going to the cloud. They could be simply moving a VM to the cloud, similar scenario, not very hard to do. But they could also be rethinking. They could be modernizing. They could be adopting new features in the cloud that can do additional things with different interfaces that they've never seen before. So the plan for what is available, what makes sense to them in their business, and how to get there, that's all part of the future architecture. In many cases, there is a hybrid cloud scenario. If you're going from premise to cloud, the transition itself is a hybrid cloud scenario. And typically, you have so much stuff on premise that going to the cloud is not an instantaneous effort anyway. So you will have a hybrid cloud scenario, whether you want one or not, at least for a period of time. Oftentimes, the hybrid cloud scenario, though, goes much further than that. We see many customers who, for various reasons, have assets in not only multiple data centers, but also multiple clouds. And it can be as a result of a merger with another company, or it can be as a result of a really great deal from one of the cloud providers, and they create a project to make an implementation there. And all of a sudden, you have networking connections and application dependencies between multiple clouds. That is not unusual, and it's probably going to happen more and more. There's a damper on that activity from the way the cloud providers sometimes charge for the movement of data, because they all think about themselves and they would love to have all the data be in their cloud. So they in a way discourage the multi-cloud scenario, but there are oftentimes even better reasons to do it, so it happens anyway. I talk about the transition architecture having to do with the length of the cutover. That's definitely part of it, but it's also about what kinds of resources are we going to need in a transient way. If we are moving a large amount of data from premise, let's say we have 600 terabytes on premise that need to move to the cloud. That's going to take a while. And in fact, in that case, you might be using a truck. I don't know if you've seen the AWS snow. I forgot. They have snow. The snowball is a small one. They also have a truck-sized one for petabytes worth of data. So the time it takes for the data to move is the time it takes to write it to disk in the truck, drive it to Amazon, and unpack it afterwards. And of course, it's all encrypted, so you're using a lot of CPU on that. But that may be what it takes, right? It may be that you have an expensive operation after the data comes into the new place where it needs to be. And this is the beauty of the cloud, you just spin up a much larger system for the duration of the cutover, for the duration of the transition. So these are reasons. A pilot might be another reason. You might be rolling this out to a limited audience first, or in a limited scale. Again, the flexibility of the cloud allows you to have a transitional view before you get to your future state architecture. And that's why we specifically have to talk about the transition architecture, because not only will it cost money specifically for these resources, but getting there and establishing it will cost some work on your part. When you look at what the customer has today, you, as an architect, as a subject matter expert, you will recognize certain patterns, right? I'm just in the center there. We have just an incomplete list of patterns you might see, right? The old Unix pattern of processes feeding data through pipes to other processes, for example, or a client-server model, or a microservices pattern. Whatever it is, one of the jobs of the architect is to recognize what patterns do exist, and then use those patterns and the pattern language, if you will, to describe what's already there, and also use the same type of language to describe what's going to be in the future architecture. This is helpful because these patterns are sort of shorthand for a long conversation. The moment I say client-server, a lot of people will have certain opinions about what that is. But it also matters because if we make a change, and if you look over to the left, if you make a change to a pattern, if you stop it, if you start it, if you move a part of the pattern to a different part of the hybrid cloud, you may actually change the dynamics of the pattern. So this is a way of talking about, I'm going to give you some examples of this in a moment, but it's a way of talking about general cases, right? It's something we can talk about way above the level of a particular vendor's implementation. If we know that this vendor in this scenario is such and such a pattern, there are certain things that are smart to do and certain things that are dumb to do, right? If a lot of data passes between two things, don't separate them too much, that type of thing. Or keep things together that has to be secured together. So there's a lot of common sense that can apply at the pattern level. Here's an example. Like, we are looking at a client-server pattern, and we are replacing it with a microservices pattern. This is an invasive process to do, and something that requires a lot of analysis of the application to figure out what types of microservices actually make sense. And notice that I'm not diving into particular Docker containers or other types of services implementations, because that is further down the stack, right? There are somebody in my company who really cares about that, and I couldn't do my job without them. But I care about the fact that it happens. I care about the fact that we are going to try and come up with the ultimate number of services, not too many, not too few, with their individual state and so on, in order for this transition to make sense and be cost effective. Here's another example where we are changing the implementation of an existing pattern. This is actually an example from one of our tools. We are able to take Oracle forms today and turn them into something else. We can turn them into a React Web UI, and then we can either keep the existing database underneath or swap it out with another one. And this makes sense because many Oracle Forms installations are no longer supportable, and there's a lot of it out there. And it's not a simple thing, so this tool is actually kind of sophisticated. There's a lot of PL SQL in the Oracle Forms that get translated, and basically it goes from the Oracle land into JavaScript and into a REST API to the backend database. But it's an example of keeping the same structural pattern, but changing out the individual components. Let's imagine a system with a lot of sensitive data that is never going to go to the cloud. This is something that you have to think about, where either for reasons of privacy or legislation in a particular country, some things cannot just go to the public cloud. It can go to perhaps a private cloud, and perhaps it stays forever on-premise. But let's say that this company is expanding their scope and starting to talk to more devices in some manner or form, and they want to leverage the cloud for that. In this case, we may actually break apart the analysis of the data between the sensitive and the less sensitive stuff that we have just added, and then have and then combine the analysis of those two sides. So in this case, we're expanding into the cloud, and we're breaking apart some of the existing functionality. This is not super unusual, and applies in many cases with really sensitive data. And of course, some of the things on the let's say it's IoT, right? IoT typically has a lot of information about things, which could be less sensitive. So it could be okay to collect over the cloud, and with its scale, it's very suitable for that. This is sort of the, from high to low, the level of abstraction that we typically operate at. And our crew of 450 or so people have these kinds of skills, right? We have account representatives who are out there in front of the customer figuring out if there's something we can help them with. The customer is always right, but the account representative is going to make them relevant to us. The solution architect, somebody like me, is going to draw pictures on the screen and say, here is where you were, here's where you're going to go, and this is what it's going to take. But that is only possible with a lot of support from a business analyst, for example, who have done exhaustive interviews with a number of key people at the customer side who knows about the workflows that data and the paperwork go through to figure out what it's really all about. And a project manager to tie it all together, because we may be deploying a team of 50 people who are all going to be kept busy for the duration of the project. And then a bunch of subject matter experts who know their own platforms, right? They may know SAP, they may know Oracle, they may know queuing or microservices. We have lots of subject matter experts who are called in to specific projects for just their thing. And then we have developers who can just code anything, right? Pick your language, they can code it. So they don't, there's nothing tying them down, but you have to tell them what they should concentrate on. So I'm wondering, when we have the question sessions, which one you are. I'm not sure how the audience today is comprised of people up and down this chain, but maybe you should think about a career DB best. This is the abstraction of the sale, right? There's a sales presentation that's making the customer's story real to them. You put some diagrams on that they can relate to. You say, this is how we are going to take you by the hand and lead you from the current to the future architecture. The Prabhat will make sure that happens, and the way he does that is with the help of the rest of the team. Somebody like me, I will put together, let's say we have a cloud implementation in AWS like we're looking at here. I'll draw these diagrams in Draw.io or some other drawing tool, and we'll play around with the needs of the solution, right? In this case, there's some replication going on, there's some redundancy, and these are all based on customer requirements. So the architect's role is to lay out the different options for achieving those ends, and communicating in a language that is recognizable. So Draw.io is very popular. It's using the symbols from AWS in this case, and at least some of the technical folks on the customer side will be able to engage in a conversation like that. But we'll always adjust the communication with the customer to what they're used to, right? So we are not hung up on particular tools or particular visual representations. We very much have to go with the flow to make the conversation effective. Maybe Vlad will help me with some business analysis. BPML is one of my favorites here. It's I think the process wars are over BPML 1, and this is an example of an online tool that anybody can use for free, in fact, to put up BPML diagrams that very clearly can sort of do the swim lane view of describing a process that moves data between things and at certain times and certain triggers or whatever. So I find this a very, very helpful view to essentially reverse engineer what a customer has. Andrew, with his good eye, will create mock-ups of the future interface. So in this case, the future interface will allow you to build a turbine. That's no small thing, actually. And we were engaged in a very exciting project to that end. And Andrew will mock it up, and we'll have a conversation with the customer. We'll say, hey, you like this? Maybe a little bit more of that, and it'll go back and forth. Oksana will maybe migrate an Oracle database from its PL SQL to something else, or she might optimize a particular part of the code, or she might write some brand new code, and she knows other databases too. I'm just using her as an example of what our DBAs do. And Andre will code our new service interface in C#, and Vlad will perhaps create this application that we also need in the solution in Java. We're not picky about the languages. We code in many different languages. The language just has to fit the job. That's the main thing, right? That's the beauty of, and the right appropriate use of languages, that they are better at certain things. Dimitri will take the infrastructure and turn it into code, right? So here's a little bit of YAML that will take care of deploying the infrastructure. So we always want the infrastructure to be redeployable. We want to be able to do it fast. We want to be able to do it in a fashion that was exactly the same as the previous time, right? So that is some of the attraction of the DevOps story, which Dimitri controls. So back to the conversation. When I have the top-level conversation with the customer, it typically starts on the whiteboard. So it's maybe a horrible-looking drawing on the top right, but believe me, people in the room, when the drawing was made, little bit by little bit, everybody understood what was going on. And then I take and make it a little, well, you can argue whether it's pretty or not, but then I make it a little bit more formalized and play it back to the customer, maybe in multiple versions. And we start using the same language over time. In this particular case, this is actually the customer for whom the cutover was going to be several months. The reason why it was going to be several months was that the data for their customers, which were in the hundreds, were spread out over many databases. And some databases were multi-tenant, where each customer had multiple records on that database. Other databases were sharded, where some customers were in one database instance and some of them were in another one. And yet again, other databases were just for the purpose of the application. So we had to sort of sort this out with respect to the cutover, because we couldn't just cut over all the databases at the same time. In this case, they were going from Oracle to SQL Server, which is sort of the hint I have between red symbols and blue symbols, that I draw a line between the current architecture and the future architecture to try and also capture that in the drawing. This is my inspiration for making drawings, the ultimate drawing. If you haven't seen this one before, you should actually go on the web and find it. Look for Charles Joseph Menard. The drawing is very famous because it folds in so many dimensions of data at the same time. This is actually Napoleon's march on Moscow, right? So the army comes out in red, and the width of the line is the size of the army. And there's the landscape underneath is the map of wherever he started in France to Moscow, right? So you lose troops all along the way. The red line gets thinner and thinner, and you get defeated in Moscow, and you return home with your tail between your legs, and you get fewer and fewer and fewer. At some point, dramatically, they cross a river, and they get many fewer at that point in time. I mean, there's a cool little divergence of troops on the outbound route that join up with the team on the homebound route. And you see the elevation of the terrain as they move along. So to me, this is a metaphor for a very deep conversation with the customer. If you can tack on multiple dimensions like I did before with the rollout, the information gets very, very packed and can be used for different audiences. Here's another example of a customer diagram. The main idea here was to show the context of the thing. The thing in the middle, this Clarity Oracle database, was what we were concentrating on, but all of these numbered items outside of that database are important, because if you swap that Oracle database out with the different platforms, all of these interfaces are going to change, right? Their queries are going to change, the ETL is going to change, the report is going to change, whatever it is. So that's an important shorthand for the scope of the project. This is actually a drawing from back when I showed you the turbine. This is an attempt at a data model for a mechanical engine. So this data model talks about the ability to connect axles with gears, that work together essentially in a gearbox. So all of these things are gearboxes, and the problem was create a 3D editor that can create gearboxes from scratch that actually can be shown in 3D and actually would work. So this data model is an attempt to demonstrate to model all of the pieces that are important for a physical gearbox to work, and they're sort of self-similar, right? These are fundamental components that are just used again and again. So I'm using it as an example to show you that you can't always stay in computer land. You can't just talk about your microservices and your C# and your ERD diagrams. You have to go domain specific. This is very domain specific to a mechanical engine. Here's another example talking about deployments. The customer has a large number of databases with an existing replication infrastructure. This has happened to be Oracle, and they have Active Data Guard moving data between the machines. Now we're going to take and lift and shift this whole environment with lower environments and production environments into AWS. How do you do that? And how do you do that without outage? Yeah, you know, if we have a terabyte of data here, or maybe it's actually way more, how do you move this to the cloud and just turn the switch and now you're online in the cloud? That's not a trivial exercise, especially when you have this many systems. So the diagram is designed to show how the data flows and is replicated ahead of time. So all of these arrows are established before we cut over, and then we just let the data replicate until it is good. Now we're caught up. Now we can flip the switch. Here's another way of looking at a rollout. This is from a previous example of the multiple months rollout where certain databases were going to be cut over at certain times. And the customers are going to be cut over these couple of 2 or 3 months, but the individual systems underneath were going to be cut over in phases. So trying to, again, depict how things happen in multiple dimensions at the same time. Here's another aspect of customer rollouts, the infrastructure of the rollout. We talk about the transition architecture, right? In this case, the customer is moving from a premise to the Google Cloud, and they also have some assets in the AWS Cloud. And one of the challenging things here is you can see there's a 300 megabit connection between premise and GCP. That's not a happy scenario. So that was highlighted at some point in the process, and we really had to do something about that because we had terabytes of data on premise, and we couldn't in any reasonable fashion push that through the 300 megabit pipe and get done in time for Christmas. So what happened here is that we put extra NIC cards on some of the systems on premise and established an alternate route into GCP. And as it turns out, the path to AWS was good enough. In order to tell that story to the customer, we created this diagram, which basically showed the timing budget of moving data from premise to the cloud. So that in this case, we were talking about MySQL, but it could have been anything. We had substantial volumes of data that had to be backed up on premise and pushed to GCP and restored on the new server. So in this case, they were actually kind of doing lift and shift. They had the VMs in GCP that were going to receive these workloads, but you still have to move the data and restore it. And by the way, you're still running in production on premise. So as all these days go by, you are still getting new logs and more stuff to move. So so that's why there's sort of two phases to the restore. The first one where you get the bulk of the data and then you have to catch up. Now, it turned out that we could actually pull this in quite a bit. It didn't take as long as this diagram shows, but the diagram definitely got people thinking, and it was the reason for why we had to do the extra NIC cards and figure out a way to make it happen. And then, of course, you have the normal rollout considerations of testing what was the new architecture before you actually turn it on, and you have to leave time for a rollback, and maybe in extreme cases you will have a rollback after you go live. We decided not to attempt that, but in that case you have to plan for also migrating the data back to the original system, which could be painful. Here's another example of a communication piece to a customer. They had a very complicated C++ application with 500,000 lines of C++ that was sitting on top of not one but two databases. So they had created their own abstraction layer over Oracle's OCI interface and the RDM interface for RAMA. Now, what they wanted from us was to, can you just move this to SQL Server? Well, that's not so simple because they were using pretty much every interface in the book. So they were using different kinds of command line tools, and they were using their direct application code to go to Oracle through multiple ways, right? ODP, which is kind of like an ADO type thing, and then ODBC as well as OCI. And the OCI interface was the largest. So the diagram in this case serves to have the conversation with both ourselves in terms of scope and the customer in terms of impact, right? We're inventorying everything that is impacted by this transition, and we're trying to have an intelligent conversation about it. And as it turns out, we replaced the OCI interface with ODBC at the end of the day. We started down a different route. We actually started by emulating OCI on SQL Server. It's going to turn out to be a bad idea, but we actually had thought about that. And then we went to ODBC, which resulted in a fair amount of rewrite in the C++ code. Now, I want to show this one, which some of you probably have seen before, Cloudcraft. They have some interesting new ideas for modeling infrastructure. I think that if you haven't checked it out, do so. Not only do they provide a very engaging editor, you see an example of that in front of you, where you can drag and drop your different things in. So it takes Draw.io to a new level in this regard. But they also have connected it to the cloud implementation. And that's really exciting. So you can think about diagrams like this becoming the future of infrastructure as code. You can they are trying to make to close the loop between the drawing like this and the underlying scripting to push out this new infrastructure and make it so, and reflect changes that happened in the infrastructure back on the drawing. So I think that's very exciting. I a little bit view the types of considerations the architect has to do as sort of a warfare in Middle-earth. This is a picture of Middle-earth from Tolkien's Lord of the Rings, and the different reigns of powers here in the landscape, and you're somewhere in the middle with your data center, and you have a change you want to make, and there are lots of forces and lots of logistics, right? Do you have to go through the dark forest, or do you have to climb over the high mountain? You know, lots of analogies here I think are reasonable, which is why I bring up Sun Tzu. Like 2,500 years ago, Sun Tzu wrote The Art of War, and it's a little bit too small to kind of read as you're seeing it right now. But when you pull out all of his general mindset, right, the mindset of the general, looking at the battlefield, looking at the objectives, then most of them apply to IT infrastructure, which is sort of surprising. And it's very much about the landscape dictates what's possible and what's affordable and cost-effective and smart to do, right? And so everything to do with people and the conditions on the ground apply. The only things that don't really apply to this is deception. He has a lot to do with deception. So if you haven't already looked into the art of war, you definitely should do that, because it is a good lesson for many reasons. So good communication with the customer is crucial. And when we do very complex problems, I mean, some of the ones I didn't talk about was figuring out what to do with 20,000 systems in a onboarding to the cloud. I mean, how do we even start to assess that? The architect's role is to draw this out, to locate the big rocks and figure out what to do with them, and then everything else falls into place. Because you pull together a team of experts who know the individual parts, and as long as you can prioritize what's hard and what's important, you'll be fine. And good drawings are crucial to this. And for me, the whiteboard is king, both virtually and in person. I do this on the whiteboard, and then maybe I memorialize things with the drawing tools afterwards, because after you leave the room, the whiteboard can be forgotten very quickly. But also think about patterns, think about recognizable bits, not just vendor names. You know, that's less interesting, but as you think about the patterns, many of the vendor products fall into the same patterns, right? So it's much easier to think about the smaller number of patterns than all of the vendors that are out there. And in fact, sometimes a particular vendor to create a compelling story blends all sorts of features into the same pile. And the architect essentially has to detangle that, because sometimes in the new environment, those functionalities belong in different systems. So think about choke points where the data has to pass through here, and that's the only way. Think about movement, and maybe study the art of war. I would like to open up to questions, and I'm going to switch back to the view of the presentation here. I'm going to stop sharing for a moment so I can do that. All right. And okay, so I see somebody has put a link to the presentation online. That's awesome. And Leo, thanks for the Cloudcraft. And do we have some questions? So I don't know. Maybe if you didn't already do them, right? So are there some questions about how we operate, how we think about things as you listen to this? Don't be shy. Write in the chat window and I'll try to address them. One of the things that are important for us when we do webinars like this is to have some feedback on how we were doing. We'd love for you to fill out the evaluation. There is, I believe, one of my colleagues is putting a Google Sheet together that will be an evaluation of the session. And yeah, like saying, the feedback will be in the survey. And we can help make these things better in the future. I'm sure that you all have other meetings to go to, and that could be part of the reason for towards the end of the presentation. But do fill that out and come back next time for another exciting topic. Thank you very much for your time today. Stay safe out there.